podcast. Hello, everyone, and thank you for joining us for the Nextcore LiDAR presentation. Thank you so much for taking time out of your day to come and hear about our technology and our company. We're very pleased and excited to be able to talk to you about the Nextcore UAV LiDAR system. My name is Ashley Cox, and I am the Chief Operating Officer for Nextcore. I also have with me today Tom Simmons, who is our hardware engineer. He manages a team that build the unit. Jared Monsieur, who is our head surveyor, who will talk to you a little bit later about his role and what he does with the company. And Josh Plowman, who's our account manager for Nextcore distributors and our customers. So today we're planning to take about an hour to talk to you, which includes plenty of time at the end for questions. We're using the Zoom webinar system. So what that means is you can see us, we can't see you, and we can't hear you. If you would like to ask us a question, there is a question and answer section to the right of your screen, which should allow you to ask any questions that you like. Allow a bit of time, because we'll probably answer your questions as we go through the system. But as we get towards the end, please feel free to ask any questions that you might have about the system. We're very happy to answer them. If we don't have time to answer them in this webinar, then we'll definitely get to you over the next week or so to talk to you. So we've already introduced ourselves. As I said, I'm the Chief Operating Officer here at Nextcore. We have Jared, who's going to talk about his role as a survey manager, as our head surveyor for the company, and how he uses Nextcore in the field. And also Tom, who's going to do some demonstrations of how the software system works, which is a key component of our Nextcore system. So, what is Nextcore and who are we? We started as a company flying drones in 2012. And that was a long time ago in the drone world to be operating drones. And we started doing a lot of different activities with drones to try and see what made commercial sense. And what we learned over time was that using drones for industrial work, things like railways and power lines and surveying jobs, was a great way to start a company, to establish a company into regular work and to be able to build from there. And as a company, what we learned to do was photogrammetry, and we learned to do that very well using drones. So we would fly our drones and we would stitch together all of our photos to create a 3D model. We still do that sometimes today. And Jared and his team use photogrammetry in certain aspects of the work that they do. It has some drawbacks though. And what we found as a company is that we needed to find a way to be able to do good survey jobs in thick vegetation, to be able to see what was going on under the trees, under the grass, and find out what was going on with the ground. And we knew that we needed to move towards some kind of LiDAR solution. And we looked at the different LiDAR solutions out there. We were a small growing company at the time. We only had about 6 staff on board, but we knew that we needed a LiDAR solution. We just couldn't afford the systems that were out there, and they were difficult and complex to use. And so what we did is we looked at the components that make up a LiDAR solution, and we built our own. And it doesn't look as smart and as good as the unit that we have today, but all of the components that we built back in about 2016 are all still very much the same components, the same workflow, the same ethic behind our company to try and create a LiDAR solution. And what we found over time is that as we were using our LiDAR solution, our clients would ask us if they could buy our LiDAR system. And so we started selling it here in Australia, which is where our company is based. We started selling it to a few of our clients. And then last year we decided, hey, this LiDAR solution seems to be working really well. Let's take it to the world. And so what we've been doing for the last 12 months is really talking to distributors and talking to customers all over the world about what our system does. What we found is we've got a really nice solution, one that is less expensive than a lot of other ones. It's much simpler to use and produces really good quality results. And that's what we want to show you about today. So as a company, our focus is on providing a system that is affordable, that achieves the accuracies that we report. What you may find if you're looking at LiDAR systems on the market is that a lot of them will report specifications based on the hardware that they purchase to put into the LiDAR system. All of our statistics that we talk about, all of our accuracy measurements that we talk about are based on real world testing that Jared and his team go out and do in the field. It's important to us that we report on how it's actually going to work. And we wanted to make it simple. It's really important that, you know, UAV systems, particularly if you're out working in the field, that we make it very difficult for you to be able to get things wrong. We make it really simple to use so that you can always produce accurate results every time. And so what we've ended up with is a hardware and software system that is very simple to use and very nice and elegant as a system. And it's a solution that is accessible to more people. It's not as expensive. It doesn't require as much learning to be able to use as a lot of the other systems. And that again is what we're going to show you today. So at its heart, our LiDAR system basically is very easy to connect. You can see here with these images that it's quite a simple system to connect to a DJI M600. Now you don't have to connect it to a DJI M600. We've got a lot of other UAV platforms that you can connect it to. But once you've established it and once you know how to connect the system, you can connect it in just a few minutes. So it means you can use your drone for other things, photogrammetry or some kind of other camera system or thermal imaging. You can use it for other things and attach it very quickly and easily. And you can take off and start flying the system as soon as you've connected it. There's not a lot of calibration and setup once you've got the system connected. And then once you land, it's simply a matter of removing the USB stick and going through the LiDAR fusion process that we're going to explain to you. And then the actual time that it takes to produce a LAS file, which is a key feature of LiDAR, is very swift. So if you do a 20-minute flight, we'll have data ready for you in 40, 50, worst case an hour. You'll have a lot of data ready to go that's highly accurate and easy to use. So the workflow is super simple and for you to manage. So the system is very user-friendly, as I said. You can see the lights on the side of the system here. Basically, they'll flash to tell you that the unit's ready to start scanning. When they go green, you're ready to start scanning. And it's a super fast processing. It's compatible with a range of different ground stations or base stations to collect RNX data. And one of the interesting things is that a lot of LiDAR units, in fact, all of the LiDAR units that I've seen, only offer a 1-year warranty. This seems strange for the amount that some LiDAR systems can cost. 2-year warranty gives you a lot more peace of mind that the system is designed to last and to work. And you can scan at quite a large area. So the two key components that go into a LiDAR system are the INS system and the actual laser scanner that goes on it. When we combine all of those along with the GPS mounting kit, all of those, we end up with a weight of about 2.4 kilos. So the actual weight of the payload is 1.8, but we need vibration isolators and GPS units and things like that to add to the system. And it will give you a flight time of around 23 minutes on an M600, but there's a range of other ones as well that you can use. So you can see here with this system, this is it attached. The important element here is these vibration isolators. So we actually remove the existing mounting system. It's simply 3 screws for each of the mounts. So that gives you a total of 12 screws that you need to remove and to attach. And then you just need to run power from the drone to the payload. After that, it's just a matter of adding the GPS aerials and you're pretty much ready to fly. So the technology, I won't go into too much of the specifications today. Again, a lot of these specifications are provided by the manufacturers. A really good example is the LiDAR that we purchase. It reports that it will give you a laser range of 150 meters. And so it would be reasonable to think when you purchase these laser scanners that you could fly at a height of 150 meters. In reality, we don't recommend flying for the RN50 system any higher than 50 or 60 meters, because although that's what it says in 80% reflectivity, the world doesn't work like that. It's more about the practical application of the system that is far more important. So in order to achieve reasonable accuracies, we suggest a flight height of 50 to 60 meters above ground level. And that should give you a good, accurate, reliable scan. So we set up our flight parameters 50 meters high and 50 meters wide. And that's a nice, simple way to sort of understand how much area you can cover with the system. Again, not too much detail we need to go into here, other than to understand that the Quantigy laser scanner has 8 lasers that spin around inside it. And each of those lasers, when they get a return, they'll actually measure 3 returns. So if we're flying over heavily vegetated areas, the laser may actually split and we'll get returns from different parts of the terrain that we're covering. So we may get one return from a tree, one return from lower down in the branches, and another one from the ground. So every one of those returns increases the chances of us getting good laser returns. And you'll see that in the data that we show you, how we're able to get those 3 returns. And it's a really important part of being able to scan highly vegetated areas, which is where our system really shines. So we use the Quantigy M8 laser scanner. It's manufactured in the USA, and we've chosen that essentially for those 3 returns that we get out of the system. It allows us to produce a fairly inexpensive LiDAR system that we find is very reliable for vegetation scanning. And we also use an INS system from Advanced Navigation. Advanced Navigation are a company that are based in Australia. They manufacture their units in Australia. For us, it's really important that we're able to source our components from reliable companion countries that are able to produce things. But having companies that are based here in Australia is a really important step for us, and has given us a lot of reliability in manufacturing systems over the last few months, particularly as it's been quite difficult to source and secure components from a lot of other countries. So one of the key components of the system that makes a big difference, and you would have noticed the GPS aerials that hang off the side of the system, and they are quite bulky compared to some other systems. But what that allows us to do is to calibrate automatically as soon as we take off. And that means that we don't need to spend time taking off and flying figure eights to calibrate our system. That can take minutes out of our scan, and we don't actually know if it's worked until we land and we process the data. So this is a far more powerful way for us to guarantee that we have calibration during the flight. And it saves us time. It's very much worth having that extra weight on board in order to be able to save that time. So now I'm going to hand over to Tom. As I said, Tom is our product manager, and he and his team actually build the systems right here in Australia.
Thanks for that, Ash. I'll just share my screen quite quickly. And what I'll do today is I'll run through basically the processing of our LiDAR solution. So this is an example that would happen after you've flown your mission. So you've taken your drone out with your RN50 attached, you've flown your mission. On our system, we have an onboard USB port, and we recommend that you fly with a USB thumb drive attached to our system. When you land your flight, the data will automatically be copied over to that USB thumb drive. You can then pull that thumb drive, insert it into your processing machine, and then start this post-processing workflow. So I've got an example data set here today. It's kind of in this back directory that you can see here. This is an example of, I think it's about a 10-minute flight. So you can see we're about half a gigabyte of data. What we'll do is we'll open that up through our Nextcore software. So this software is included with our system. So we'll process this data set. This example flight is actually calibrated out in Fiji. Great spots. Let me open this up. So the first thing to note is that all flights that are conducted by our RN50 are time-stamped using a UTC time format. So this one was flown on November the 17th in UTC. I'll open this up. So we can see here we're on our landing page of our processing tab. I'll just zoom out a little bit to show you where in the world this was captured. So this is Fiji. This was a mission that was conducted as part of a real-world surveying job conducted by Jared, who you'll hear from next. We can see here that this is the raw path that the RN50 has taken throughout this mission. We don't connect to the flight controller, so this is all independent of that. And the first step for us to do in our post-processing workflow is to basically pair this with example RNX data. So I imagine many of you will be familiar with the terminology PPK. That's essentially what we're going to apply to our raw telemetry path here. So we would select our RNX file from a base station located approximately within the 10 kilometers of this kind of flight. And we could then post-process our flight. To save a bit of time during this webinar, I've already processed this flight. And you can see up in this dataset details tab in the top right-hand corner that this was an 8-minute flight, and I do have a post-processed IMU/GNSS. This is the step that Ash was talking about before that takes traditionally 2 to 3 times your flight time. So for this 8-minute flight, I'd expect that this RNX would take roughly anywhere from 15 to 25 minutes to kind of process. Once processed, we can kind of look at the health of the processing and see that we've got a 100% post-processing fix rate, which is really good for PPK. For a UAV LiDAR like this, I'd expect above 95%, and the average separation of about 60 mil, which is quite good. So once we've done our post-processing, we'll come over to our Fusion and we'll start selecting data that we want to include into our LAS file. So the first thing to do is actually on this left-hand side here, where we can see these flight lines. So our system automatically detects the different flight lines flown and tries to categorize them. So the first thing to do would be to guess these flight lines and pick these long linear flights here, coming down the middle, as we don't really want this data that's coming across between the 2 flight lines shown here. And we also don't want to include the data coming from the landing site or the takeoff point to the start of our grid mission. So we can see that our guess flight lines function hasn't correctly got rid of these 2 coming towards the flight. That's not a worry because we can just manually deselect these flights. There we go, we've got 3 really nice long flights. This is quite a heavily vegetated area and it was quite a mountainous terrain, but these 3 flights should be quite good flight lines for getting the appropriate area of interest coverage. So once we've selected our flight lines, we want to then detect, basically set our Fusion settings, which is some really simple variables to kind of limit the amount of data that we're putting into our LAS file. So this includes setting the minimum distance from the sensor. So this is just, we've set this at about 1 meter to reduce the points that we get from the drone. The maximum distance that we'll accept from the sensor, we usually keep this anywhere between 75 to 100 meters. Our sensor is rated to 150 meters, but as Ash said before, we really focus on real world results, and we find that anywhere between 75 and 100 meters is quite good. This flight was flown at a 50 meter AGL, and so with a 100 meter maximum distance, we should get about 120 meters swath. We've also got a cut degrees. So our sensor is a 360 degree sensor. So it does mean that it will be capturing points above it. We do cut off 160 degrees of those points as we don't particularly want the returns off the drone itself. It's also at this step that we can run a really basic limiting of data coming to the system and edit these decimation settings here. But we tend to leave these blank and then do what we call a full decimation down in this little bottom tab. And this essentially looks at all three flight lines and starts to limit the amount of data overlap. By saying that, I mean that when we're flying like this, we don't particularly want data, say, from this red flight line here underneath this green flight line, as the data underneath this green flight line will be far more accurate than the red flight line at this particular spot underneath the line. So this decimation starts to look at that and culls that, and also does a really basic filtering to try and reduce the number of points in an effective way that basically shows the best possible data. Here we can also select the exports. So once we've set our Fusion settings, we can move over to our exports tab. Here's where we want to select where the path is to basically drop this data. We can also determine now if we only want the selected flight lines, whether we want like a single LAS file and compress it to LAZ. Here's where we can also set the projection of our system. So in this one, we're going to use a UTM, a Fiji UTM zone 60, I believe. Yeah, 60S. So we'll select that. And then we'll start processing now. I've got a little warning here that I have less than 20 gigabytes of storage, but that should be okay. So while this is processing, I should mention that we can bypass this PPK process and go straight to this exports tab. So in theory, you can do this out in the field. So what that means is, if you're out at a very hard to access area and you want to make sure that you've got all the possible data before you return home, you can do this processing out in the field on your laptop. The processing done today is just on my local machine here. I'm just running an i7 with about 16 gig of RAM, which is a little bit more than you probably need. We can operate up to, on anything, I think an i5 up to 4 gigabytes of RAM. Should be sufficient enough to process this type of data. And this is where we see a major difference between LiDAR and photogrammetry, is the processing requirements, as LiDAR is nowhere near as intensive as that kind of pixel mapping that you get with photogrammetry. So here we can see that our progress bar is kind of fulfilling. What it's doing at the moment is writing the LAS files for each different flight line. It will then start to run a decimation, and that's where it's looking at that kind of overall decimation that I was talking about before. And then we'll develop some map overlays to help us determine if this flight was a success, as well as develop a trajectory file. So the Nextcore software actually develops a trajectory file, which is just a CSV file that has the XY positions of the flight path. And this is a really cool tool to help you when you're back in the office, understand how the mission was captured, and a little bit for accuracy proofing. We can see that that LiDAR is almost done now. So now we'll start our decimation step. This happens automatically in the background. Should be fairly quick for this flight. This decimation can take a little bit longer if you've got many more flight lines. But we'll finish up fairly soon. And I'll talk about the map overlays in a second once they're been developed. But this is all writing into my local machine in that directory. That's just in this exports folder here. We can kind of see that it's developing its different flight lines and writing that LAS file at the moment. Should also note that all the dataset details are up in this right-hand corner. And that at this point, I could theoretically come in and open up these LAS files. I don't have to wait for this decimation step. Awesome. So now we're finished processing. So this was only an 8-minute flight, and I think that took us about 2 minutes to process. And now we can see what we call these map overlays, which give you some info on how the mission was flown and what kind of coverages you've got. So including the maximum height of the area, the minimum heights, average heights, Probably most importantly is this point density, where we can see how the area was covered and what type of point density we have, red indicating that we've got a high point density, with blue being a little bit less. If we do see blue though, we would expect that to be a good mission. This is a really good way to tell that you've got all of your coverages correct before leaving your job site. I'll move that down and we'll open up that data directory. So you can see that I've got my decimated file here. I'll open that up today in a program called Cloud Compare. I've already processed this, so I've opened it up already. But these are our 3 flight lines as developed by our system. We can see that we color according to our point source ID, which is our flight lines. But we can also change that to any of the LiDAR metadata fields consistent with LAS files. So I'll put it as intensity at the moment. We can see the different intensity map. We can kind of see our area of interest here. You can kind of see how hilly and how mountainous this terrain was. There's a little building in here. Hopefully this is portraying over zoom correctly. That's our intensity values here. What's another interesting point to note is the number of returns. So here you can see what return number each point was. So as Ash mentioned before, we are a triple return system. And through this thick vegetation here, we've got really showing where this technology shines in the multiple returns. And you can see we're getting a number of first and second and third returns through this vegetation. And this is giving us really good ground coverage so that we can develop our DTMs and other surveying deliverables after this. I'll let Jared speak a little bit more about what to do with your data once you've collected your LAS file. I'll pass it on to him at the moment.
Okay, thanks, Tom.
I'm muted. Sorry, 1 second, Jared. Just while I pass on between you two, we just had a couple of questions. One I think I know the answer to, but I might just check with Tom. The Trimble R10s, are they compatible as a base station with our system? I believe they would be.
Absolutely. Yeah, that's a quality receiver. It'll be fine.
Very good. Yep, that's the sort of base station we'd all like to have.
Yeah.
And the other question is, and I think I know the answer, but I'll get one of you guys to answer this more accurately, is how many points per square meter are achievable on densely vegetated area and on non-obstructive surfaces like roads?
Okay, we aim for about 400 points per square meter, but that's flying at about 50 meters at about 8 meters per second. And that's more than enough to get your ground penetration, as well as pick up other features like line markings on roads and that sort of thing.
Yeah. So typically, Jared, if I've got this right, we end up with more points per square meter than we really want to use, and that's something that you'll go into in this discussion here about those point returns.
Absolutely. My theory is less is more. But less good data, which is what Nextcore is about. Okay, so a bit of background on me. I am a surveyor. I work for the sister company Airsite. We were the founder of Nextcore. All the examples I'm going to go through are real world solutions and real world data sets that have been captured for real jobs and delivered. The job that Tom talked about was a 16-kilometer pipeline job in Fiji. It's heavily vegetated, so I'll just talk about vegetation for a second. UAV LiDAR offers a huge opportunity to survey areas that were not able to be captured by conventional methods or infeasible to do so. So capturing LiDAR data so close to the ground gives an opportunity to measure the ground points and use that point cloud data to extract surface models and contours. Just like on your screen there. So yeah, you could see the contours. They are 1 meter contours, 5 meter major contours there. You can see how much the topography changes there. It's mountainous terrain. You can also see Chris, one of our surveyors, gazing over Fiji there. I think he was just picking up some check shots. Okay, pictured here, we can just see a cross-section of the same Fiji data set. The point cloud shown, it shows the point cloud with the surface model running underneath. So that surface model has been extracted from that point cloud. Now, I think Nextcore's difference in vegetated environments is utilizing that quantity sensor. So with the 3 returns to every laser, it really helps to reach the ground in thick vegetation. As like on a job here, where we've flown at 50 to 60 meter, Nextcore produces accurate and really dense data. So these 3 things combined, the 3 returns, the accuracy and the density, gives incredible performance in vegetation. And by performance, I mean the ability to penetrate vegetation and collect data that's on the ground that is fit for purpose for extracting surface models. On this slide, we can see the same data set again. You can now see the trajectory that the drone took on this particular mission. So the data was collected with terrain follow, which isn't a requirement for the system, but it helps us improve the data set and maintain a constant density by traveling the drone along the same height from the ground. And it gives us the best chance to achieve good ground returns. Nextcore has some great processing features that gives this user a high level of control over what is actually exported, and it also removes all the unnecessary data. So points that are too close together or overlap from your flight lines, this data is omitted straight away because you don't need it. However, the reduction of these points doesn't take away from the quality of the raw data set, keeping all the important ground returns. This is the same data set again. I just wanted to point out that UAV LiDAR and Nextcore is exceptional in surveying steep or difficult to access terrain. This data set is a great example of this. We can see how mountainous the terrain is there, and you would not be able to survey this conventionally. Okay, so moving on to power lines. It's another excellent use case for the Nextcore LiDAR solution. The image on the right was captured about 20 meters from object, and you can see the detail in the point cloud is perfect for feature extraction of many important survey layers, such as attachment points or conductor modeling. We can even see the insulators there in great detail. This information can be captured and delivered with great efficiency and is super valuable for overhead power line design projects. Okay, so linear projects like power lines are well suited for the Nextcore capture and processing workflows. There's no need to be near the base station during your flights, so you can cover a lot of ground in a single day. You can even use multiple receivers to speed up productivity. You can process against local base or core stations. So projects like power lines or road projects or rail projects can see huge efficiency gains using Nextcore LiDAR. Okay, so another huge benefit to Nextcore LiDAR is there's no requirement for ground control. So using this scenario, we can solve a lot of safety issues. The image to the right you can see there is an ash dam that we survey regularly. There's no access to the dam. It isn't safe to walk there. So, but we can fly the drone with Nextcore LiDAR on it and collect all the surveyed data there without ever accessing the dangerous area. Okay, so the Nextcore solution, in terms of monitoring surveys, it is accurate enough and repeatable enough so that we can survey the same area again and again and compare the two or multiple data sets for change over time. Applications such as environmental monitoring or mining and quarries are suitable for these type of surveys. We can undertake these surveys for reporting volumes on a regular basis and create deliverables like we see there. As well, the Quantigy sensor has a really high ability to return reflectivity values that can be used to produce other deliverables. The image to the right, we're able to extract road markings and other features such as signs and road barriers to create a digitized survey model that was used in a road safety project. Okay, so accuracy proofing. All our accuracies are independent surveys. We have a team of surveyors that use Nextcore every day. We proof the system for accuracy regularly. We test the new hardware and the software to make sure that it is suitable for real-world surveying applications. This makes our solution the most usable and practical. Okay, so pictured here, we were given the opportunity to test the Nextcore solution against a conventional ground survey that had already been undertaken. So it was the conventional survey was they used RTK GPS as well as the total station. The image shows here the two contours of the same site. The blue is using contours generated from the conventional survey, and the red is generated from our LiDAR survey. As you can see, the contours match perfectly. The conventional ground survey took about 2 months to complete, while the Nextcore LiDAR survey was completed in 3 hours. Okay, so why we use Nextcore for our aerial surveying projects? It's the most cost-effective solution on the market. The GNS workflows are efficient and powerful. The software is free, so we don't need to price any additional subscription costs into our pricing. The processing is fast and can be done on a standard laptop. And Nextcore produces usable point cloud data that is really easy to work with. Thanks, guys. Ash, can you unmute yourself?
Sorry, everyone. I had some noise outside. I was trying to quiet it down. Thanks very much, Jared. I could see we've had questions coming in, and Tom's been madly trying to address those. So we'll get to as many of those as we can. We've actually got a bit of time. So if you do have questions, please put them into the system, and we'll try and get to them now. If we can't get to them now, then Josh is going to follow up with you and answer any questions that you've got. And we'll show you Josh's email address later on in these slides, just so you've got that. In terms of pricing, and someone mentioned in the Q&A, there is an RN80 system. Now, we've talked about our RN50 system because we haven't quite launched our RN80 system, and it's kind of the world's worst kept secret. We will be launching that very soon. We're just finalizing the commissioning and testing of that system. And the difference between the RN50 and the RN80 is that the RN50, we recommend you fly it at about 50 or 60 meters AGL. The RN80, you'll be able to fly higher. And the reason that you can fly higher is it will be a more powerful laser scanner and a more powerful INS system, a more accurate INS system that will allow us to achieve the same accuracies at a higher flight height. So if you're regularly flying at very steep terrain, and you want additional altitude to be able to clear mountains and trees and power lines, then you'll be able to purchase another system. But at the moment, the RN50 system retails at a price of $45,000 US. Now, depending on the country you're in, there may be a distributor or there may not. If you'd like to be introduced to the distributor in your country, then again, we suggest you contact Josh and he'll put you in touch with your distributor. If there's not, then contact us and we can work out a way to get you a system into your country. And we often do that where we don't have a distributor. Also, if you're thinking of becoming a distributor, please reach out. We're happy to discuss the process of becoming a distributor if that's what you are looking to do. Just to cover off on a few key elements around production and delivery. So Josh is our account manager. He'll look after you, and his email address is there. It's joshplowman@nextcore.co. And he's happy to speak with you further about the system and how you go about purchasing a system. Now, we have had a large increase in the demand for systems over the last few months. And Tom and his team are very busy working at trying to get enough units on the shelf so that we can ship on the day that we get an order. And that's our intention. We have had some delays in production though, because we've had more orders than we expected. This is our facility here in Australia. Everything's hand built here in Australia. We order all our parts in from our suppliers. We build and test everything ourselves. And we support the system as well. So it's super important to us that we build a unit that requires minimal support and that every customer is shipped a very high quality unit. So that's especially important to us. So I might just address a couple of the questions that have come in. And if you have more questions, now's the time to put into the system, and please feel free to ask those. There's a couple of questions that I noticed come through. Some of them I noticed that we were able to answer. Jordan, just in terms of the RN80 costs, we haven't finalized the pricing yet, but I'm expecting that to come in at around $60,000 US. So it is more expensive than the RN50. The components of that are more expensive. In terms of the DJI M300, there's a barrier with a lot of smaller drones, and that is that the legs on those drones don't retract, and it's the same with the M300. What that does is that reduces your scan angle to be able to do it. At the moment, the RN80 and the RN50 solution will not work on an M300. There is a range of other drones that the unit will work on, but at the moment, that's not a viable option for the system, and we'd recommend that you go with the M600 in order to guarantee the flight time and also increase that scan angle and allow you to cover a reasonable area. Another question I noticed that came in was around the colorization of your point cloud. Now, again, at 50 meters high, your ability to create an accurate coverage of an ortho to be able to layer on top of your LiDAR model is you're going to be making a lot of exceptions to how you do that. You're going to have to be collecting lots of high quality photos at a very low altitude. What Jared and his team do is they will take a smaller drone with them, like a Mavic or a Phantom, and they'll actually fly the same flight path that they do with the LiDAR before they take off. And they do that to make sure that they don't crash their expensive LiDAR payload. And then what they do at the end of that is they can then use the Mavic to fly up very high, say 120 meters, and do a quick mission with an RGB camera to collect that colorization. It seems like an additional work, but what happens is you get better flight time. You don't have to sacrifice how high you're flying, and you can process the colorization far more quickly. It's also worth noting that there isn't a big requirement for colorization. You can see in most of the data that we're collecting, we don't actively need to colorize it. It's not giving us additional data that we usually need. There are some circumstances where you need it. So at this stage, that's not available. Now with the RN80, we're starting to fly higher with our systems, and it means we will be working on a colorization process in the future. But at the moment, I would say that the colorization system isn't available, and the workaround we would suggest is doing that. In terms of a thermal sensor, at this stage, your distributor or a distributor in your country may be interested in integrating. And in fact, I think Tom would like to answer that question.
Yes. There we go. You want to mute yours. So with with the thermal sensor, we don't have it on the roadmap at the moment to integrate that into our system. But we are independent of the drone platform. So if you did want to integrate a thermal sensor onto the UAV at the same time as our system, that is feasible, and that could be possible.
Right. So here's an interesting question. Jared, we're probably going to need you to help us answer this. What are the accuracy values when comparing the RTK GPS on hard edge objects like curb line? Would you expect these at plus or minus 20 millimeters?
Okay, so accuracy. So I was just about to post here, the system is plus or minus 50 mil. So I'll do that. You're not going to be able to pick up curb lines and that sort of survey detail as you would conventionally. However, you can pull features out like that because you can see these features, but you can't really give it an accurate Z value. So it's not really suitable for like road design when you're tying in curb lines and that sort of thing, but it is appropriate for like GIS planning solutions or projects.
We've had a question here from Jonathan. Hi, Jonathan. We've met a couple of times before now. There's a question there around if it's a wider corridor and you want 2 or 3 flight lines, are you best flying in smaller zigzag segments, or can I come back a few hours later? I fly from south to north of a 15K corridor and then fly from north to south. I would suggest probably scanning in smaller segments. Tom, is that what you would recommend in that circumstance?
I think I'll answer that one. I think the smaller sections would work better. Our flight planning is usually in rectangles. So we try and keep the drone at the same heading and fly perfect rectangles where possible. And we try to keep the distance of one flight line from about 750 meters to 1 kilometer. We have done longer and we have done shorter. Just depends on the area of interest.
Yep. And we've also got a question in there just about becoming a distributor. If you would like to become a distributor in your country, I suggest you reach out to Josh Plowman at nextcore.co to go through that process of becoming a distributor, if that's what you would like to do. We like to get to know our distributors and make sure that they're going to be able to support our clients out in the field with their systems. But yeah, very happy to discuss distribution with you. In terms of pricing, there was a question there about the pricing of the actual drone. So the price of the drone is variable depending on what sort of system you want to attach. The DJI M600, I think you probably can get up and flying for around the 6,000 US mark, which would probably include your batteries and your drone to get going with that. But there's variation there, and there's a lot of variation in the system. For example, we're working with a company in the Netherlands at the moment who have a drone that's capable of a lot more flight time. If you want to have a look at that, that company is called AceCore, ACECORE, AceCore. Their unit, I believe, for their larger unit, which would give you a lot more flight time, you'd be looking at probably around the 30,000 US mark for a system like that. So there's a lot of variation depending on what you need the system to do and how much flight time you need and all of those sorts of elements as well. But we're happy to make recommendations to you if you've got any specific questions around any of that. The other question we got was around what software do we use for our mission planning. Now, you're able to use whatever software you like for your mission planning. There's no mission planning software in what we do. So the flight lines that you saw in the processing are just us recording where the drone actually went or where the payload went from the INS and the GPS in the system. So you can use whatever you want. We use and we recommend Drone Harmony. And the reason that we do that is that we want our drone to be able to follow a consistent height above the ground at all times. So I recommended before that we fly at 50 to 60 meters above the ground. if we don't use a terrain following mission, we're going to have points where we get too far away from the ground and other points where we're really close and possibly too close to trees and power lines. So the two main ones that we use and recommend are Drone Harmony and UGCS. They seem to work really nicely for the type of mission planning that we need to do, but you can use whatever system you would like to make that work. But we do recommend you use one that allows for terrain following in the options. I haven't seen any more questions come in, but we've had a lot of questions coming in, which is fantastic, and we do want to get to all of those. Great question, Tony, about the power from the system. So what happens is the system doesn't have its own power. We take the power from the battery capacity on the drone, and the first question we get is, will that reduce my flight time? The answer is no. The laser scanner actually uses just a very small amount of power. So the draw that it takes out of the batteries doesn't really reduce your flight time in any noticeable way. It would be less than even a minute of flight time that it would take from the system. So you can essentially take that from the drone. It is possible to rig up an alternative power source, but of course then you're adding the extra weight from an additional battery. So the solution that we've got on board for the DJI M600 is to just take power from the actual landing gear power. So the power that runs to the motors to retract the landing gear, we tap into that power, and that allows us to power the system. And there's very negligible difference between the operation of that. So hopefully that answers your question. So yeah, that's an all-in-one system, and we provide all the cables and system that you need to be able to do that. The terrain following software that we recommend is third-party software. So the processing software that we use is a really important element. I didn't really talk about it enough. It's included in the cost of the system. There's no subscription fee with our system. What we found with a lot of the LiDAR systems when we were looking for one was that you would buy the hardware and then you had to buy third-party software, sometimes 2 or 3 different kinds of software to get to the processing. This is an all-in-one system. There's no other third-party charges. But for the drone flight planning, you do have additional software costs for that. You can use the DJI flight planning system, which is included with DJI, but we would possibly recommend something like Drone Harmony. I think you'll find it's relatively inexpensive to use that sort of software. Okay, well, thank you very much, Malcolm. That's a great compliment. We're really proud of the system that we've created, and as you can see here, I've got a great team that actively use this system in the field all the time. And I think the fact that we are selling the unit because we built it and we tested it and we've sold it to clients here in Australia over the last few years, we're really confident in it, and we're really happy with the quality of the outcome that and the price that the system is available at. So thank you very much for that. In terms of Jonathan, to your question about what I suspect is converting the system into a mobile laser scanner, can I attach it to a vehicle? We don't recommend it, and we don't support that use case. We've designed it very specifically to be used on a drone. And there's a number of reasons into that I won't go into today, but we recommend the system, and we've designed the system to fit to a drone. There's a few engineering challenges with using it as a mobile laser scanner, as well as some additional costs and things like that. We may produce a mobile laser scanning system in the future, but at this stage, we're very much focused on the UAV world, which is where we get the bulk of the use from the system. My country does not have any reliable cause system. What other method of referencing can I use? So basically, we would recommend that you use a base station, an L1, L2 type of base station. If you write to Josh, we can give you a couple of examples of systems that work in various price ranges. You'll notice someone in the webinar mentioned that they've got a Trimble R10. This is a very high quality base station, and I'm sure Jared would love to get his hands on one. But there's a range of other ones that will work sufficiently well to be paired with our system. It's possible that you may purchase a base station that we haven't used with our system before, and in which case we're very happy to work with you to try and get that system working with ours. There's usually not too much of a barrier there, as long as it's an L1, L2. Tony says, how do you extract the final DTM ground surface? Is this just done via the ground extraction in 3D Reshaper? I know the answer to that, but I'll let Jared answer.
Hi, Tony. Yeah, it is. It's done all the analytical stuff is done in third-party software. So depending on the application, we're gonna choose different survey software packages. So for ground extraction, we do use 3D Reshaper, yes.
Yep. So, but you know, the focus, I guess, from our company's perspective is we don't want to get into the space of providing software that goes into the deeper analytics and feature extraction of LiDAR. It's really important for us to produce a LiDAR system that that just gives you an accurate LAS file really quickly, and allows you to understand that you've done a good job, you've got the data that you need, and then we don't really want to be competing with the likes of companies like Hexagon and all the other ones out there that can do all sorts of amazing things once you've actually got your point cloud ready to go. So for us, it's really simple for us to be able to get through to it's important to make that a simple and easy to use process. So I would like to very much thank everybody who's come along to this webinar. We've had a fantastic turnout for this webinar, which is great. And I hope you've all got a lot of information out of it. Please feel free to reach out to us. We're very happy to discuss anything with you further and to organise a one-on-one meeting with you, or perhaps you need to convince someone in your organisation that it's a good quality system or how it's going to work. We're really happy to discuss that, you know, within your organisation to help you do that and to introduce you to distributors who may be in your country as well. So yeah, please feel free. Thank you very much. And a big thank you to our panelists today too, particularly Tom, Jared and Josh, who this is their third webinar in the last 24 hours, I believe, or a bit more. So they've had some early mornings and some late nights. So thank you very much. And yeah, look forward to working with you in the future. Have a great day.
Thanks, everyone.
The other thing I should mention, if you'd like a copy of this recording or the presentation that we did today, again, please just email Josh Plowman at nextcore.co, and we'll be very happy to send you a copy of that. Thanks very much, guys. Have a great day.